All right, good afternoon, everybody. I hope you had a good lunch so we can um, stay focused on what we're learning today. Today we are learning about how to navigate in the pursuit of a career in engineering. As we all know, we had some career events that focuses on a lot of engineering degrees. So today, Dr. Harding will tell us all about it. So, but before that, let's do a little check-in. As you know, you need to check in so that your teachers know that you are here. And if you have questions, this is a great questions document that you can reference to. And the most important thing is the evaluation form. This is how we give you attendance and credit for attending this event. Be fully present, ask the question, and pay attention. You can turn on your camera. You can ask the questions in the chat. And if you turn on your camera, don't worry, you're not going to be on the recording. Again, submit your evaluation. This is very important right after this event. This is how we give you credit and a requirement for high school student to graduate in Oregon. And that is it about me. Let's have Dr. Harding.
Great, thank you, Goldilocks. Yeah, and welcome everybody. And as I'm sharing my screen, it would be great to have people on camera so we can have a successful and productive interaction. So thank you. Thank you, Karen. And I'll go ahead and wait for people.
So we have a whole school of students in Hillsborough High. So if you wanna, you can get started if you want.
Okay, so do people not have cameras? All right, well, is it a high school or a classroom?
I think there's like a class. They're using one computer in one classroom.
Okay. All right, well, I will go ahead and speak to black boxes then. So good afternoon, everybody. And I'm not sure how many people are out there, but it's great to have an audience out there. So the title of my talk is very intentional. What I'm trying to do is to make it so all of you are less intimidated by the prospects of a professional career, and that really the future is bright for you. If you're interested in something, there's a lot of fun to have. And that's why I title it Happily Navigating the Pursuit of a Career, because you don't need to be worried. All right. I'll talk about my own career a little bit as we go, but that's really the objective of the talk, is to get you excited about the possibilities out there and how much fun there is to have. So to accomplish that, we're going to talk about what is an engineer, and this will be interactive. So everybody prepare to engage in the chat room. And that's how we're going to go ahead and find out what everyone's thinking out there. So thanks in advance for that. So prepare as we move along. And then I want to have some fun with what does an engineer look like? And I want to get your input on that, because I think there are a lot of stereotypes about that. I'm going to talk about my background a little bit, because I think you'll be interested, and it might give you also some perspectives about that. Maybe my appearance is one thing, but where I came from is another, and it might help you understand how people from unusual backgrounds can have a professional career. We'll talk about types of engineers, and I'll be asking you what you like or don't like about each type we discuss. And then finally, for me, the most important part is to talk with you about what sort of things you need to do to make it possible in the future. So let's start with what is an engineer? So go ahead and talk amongst yourselves. If you're alone, use the chat area, but let's take a minute. I'm going to pause for a minute, and I would like you to type into the chat box what you think an engineer is. Go ahead. Great, I see some responses coming in. Well, one response from Goldilocks, thank you.
We have one more. She just direct messaged it to me instead of everybody.
Great. And thank you, Karen. And Karen, are you a teacher?
No, I am not a teacher. I work here at the School to Career program. Today's my first day.
Oh, really?
Mhm.
Congratulations.
Thank you.
Okay, we got one response from Hillsborough High. If I'm understanding, we have a classroom. So it'd be great to have a few more responses. Jeffrey, how about Jeffrey? You could go back on mute, please, Karen. All right, more from Hillsborough High and maybe Jeffrey. There's another one. Great. So one response from Hillsborough High was someone who builds stuff. And another one was an expert in what they do, who creates things and has creative ideas. How about some more from Hillsborough? And we're still waiting for Jeffrey. There's Jeffrey. Someone who goes to a four-year college to study in a building or creating things. Good. Thank you, Jeffrey. How about one more from Hillsborough? We got to start practicing those interactions, okay? So thank you, Hillsborough High. Someone who creates structures for a certain job. Very interesting. So really a focus in your responses on building things and structures. Really interesting. So let's go now to back to the presentation, and this is the definition I use. There's a lot of words here, so let's go through this. A person who uses scientific knowledge to solve problems. That's a lot of words, but really you might think of it as just someone who uses like chemistry and physics and math that you'll take somewhere down the road, or maybe you're taking now, to solve problems. So you take things you learn in the classroom and you apply it to make people's lives better. That's what an engineer is. So what does an engineer look like? Let's go through another interactive activity. And this one, don't be shy, okay? If you have stereotypes, anything about an engineer, if you want to have a little fun, it's okay. For example, I have a pocket protector, okay? So have some fun, and so let's start typing some things in. Thank you, Goldilocks. Wears a hard hat, very good. Hillsborough High looks rough, unshowered. Yay, thank you, Karen. Women, yes. Oh, that's a good one. Hillsborough High, bald with glasses and a pocket protector. So that's me. So well done. That's one answer. Okay, so Jeffrey, thank you. But really what I'm asking is what do they look like? Oh, what does that mean, Karen? BIPOC.
Black, Indigenous, people of color.
Oh, thank you. Okay, good. Karen is a step ahead, and I'm so excited to have her on the team. So let's start by having a little bit of fun with this, and take a look here. So here's what engineers looked like maybe 50 years ago. What do they all have in common? I know Karen has an answer, but let's see if we can hear from students a little bit. So students, what do these folks have in common? White men, right? Jeffrey, rulers. Actually, thank you for writing that. So losing hair, yeah. So and Jeffrey, thank you for writing rulers. So those are actually called slide rules. That's what existed before calculators came about in the 1970s. Slide rule is a way to do calculations without a calculator. And so engineers at that time were experts in using slide rules. So when I thought about this and trying to make all of you feel very, very welcome in the engineering field, it struck me that, and as we say, well, what do they look like today? That maybe the best way to do that, because I'm a former professor of chemical engineering, that I would go back and look for pictures of my former students. And a place to do that is a professional social media platform called LinkedIn. It's not social media, it's professional media. So I went and I did a filter and searched out my students. So let's take a look at what they look like from the last 10 years. I'd like you all now to take a few minutes and tell me what you're excited to see and type it into the chat room. Great, keep them coming. What other observations? Great, a lot of women, diversity, excited in the change from how it was before. How diverse engineers look now. Many women, a lot of differences from before. More women, more people of color, wide range of ages, and that's a little deceptive, but that's somewhat true. So a lot of folks come back to college at a later age. And I love this one, Hillsborough High, they're smiling. That's right. So that's part of the happily navigating piece, right? So it's important to me that everyone on this call, including the teachers and the coordinators, see that even though we still think of so many of these professional jobs as being dominated by white men, I just want you all to know that that has changed. And there's a lot of excitement and energy in all fields, but especially engineering. And all of these people I adore. They're my former students, and it was great to be a teacher. They're smiling probably because they decided what they wanted to do, and they worked they worked hard, they interacted with others, and they ended up getting a job, and they're working. So, and we'll come back to that too. So thank you for your engagement. I really like the they're smiling input. Okay, I wanted to tell you a little bit about myself, because at first blush you might think that that I have sort of a standard background, but I wanted to share with you first my mother, Vera Lucia Soares Pulcão. She was a first generation Brazilian immigrant, came here bravely by herself at age 20 and worked her way through college, and met my father, who's not Phil Senior, but he's also Phil Harding, and they got married. My dad had some challenges, and so my mother raised 4 of us by herself. So I'm the little kid on the farthest on the right, under my mother's left arm, and I was the oldest of 4, and I helped my mother manage everything, including this 1970 Volkswagen Beetle. And so the reason I show you this picture is because when you look at other people, it's very tempting to draw conclusions about what their life was like, and whether they had advantages or disadvantages. And it's also my way of connecting with all of you, you know, whether it's someone of color or someone who doesn't have a lot of resources. I would sneak into the back of the cafeteria to get my free lunch tickets, and I don't regret any of that. And so I want all of you to know that you can become an engineer from any background, and you're going to be welcome. So that's the point of the last 2 exercises. Okay. All right. So now I'm going to go through. Now this is a lot of stuff, but it's basically my personal path. And I want to start by saying something that may surprise you, and that is that I never had any goals or ambition. So now I'm currently the vice president of applications for a company, and but I really had guiding principles of just working hard and having fun and enjoying the people around me. And when you do that, good things happen. But let's go through my life story very, very quickly. So I went to high school in Corvallis. Then I got a scholarship and went to Oregon State. And so that scholarship changed my life, and so forever grateful to the donors. I then worked in the paper industry for a few years, and then I wanted to go back to school. So I went to what's called graduate school. First, I got a master's degree in paper science. Then I went to the University of Washington, pardon me, and I did a PhD in chemical engineering. And my confidence really started to rise that I could do a variety of things. I then went to Hewlett Packard for a decade, worked there for 10 years in research and development. And then I became the Linus Pauling Chair at Oregon State University in chemical engineering, and had a chance to do a lot in my 12 years there, including working with a lot of companies sort of listed around the Oregon State Beaver there. I'm assuming everyone on the call is an Oregon State Beaver fan. All right, so then after 12 years, I wanted to do something different. And so I went back into industry, and I went back into paper making because I had a dedication to sustainability. And this company was beginning to develop paper made from non-tree fibers, or what we call alternative fibers. And I did that for 2 years. I learned a lot, and I was so excited by it that I wanted to do it on a larger scale. So I joined the company shown behind me. So this is our plant in Eastern Washington, where we convert waste wheat straw to fiber for paper making and making dishes and things like that. So Columbia Pulp, I've been here now for less than a year. I was promoted quite quickly to vice president of applications, meaning that I figure out where to apply the fibers, and that's been great. And so that's my career in a nutshell. Does anyone have any questions about why? And again, before I open for questions, you'll see it might look like a very deliberate path, but I really never had any goals or ambition. I just wanted to have fun and be challenged. I wanted to wake up in the morning and not be sure that I could succeed. So any questions about my career or specific companies or universities?
Before you went to high school, what is that chevron and the other thing?
These two symbols here.
Yes.
So after high school, I started at Oregon State and I had summer internships with Chevron and with a company called James River. And then I finished my bachelor's degree. So this is, thank you for asking, Goldie. Like, these are references to my internships. Any other questions? Okay. So let's start to talk about what engineering is. So what I've done here is basically to get us started with a whole bunch of things that an engineer or environments in which an engineer might work. And then we're going to go down to specific engineering fields to help you understand some of the possibilities. So engineers can work in all of these different fields, and there are different kinds of engineers we're going to talk about. We'll talk about a few of them. So chemical process industry. So if you look around you, you see plastics, bottles, paint, everything around you basically came from an engineer. Wastewater treatment, every ounce of water that goes out your sink or your whatever is going to get treated, and engineers are involved in that. Photovoltaic, so that's solar panels, photovoltaic. Engineers design and make those. Medical devices, helping people feel better, survive surgeries, things like that. Pulp and paper, the industry that I'm in now, in my case, making paper from non-tree fibers. In situ bioremediation, what that means is in situ means in place, and bioremediation is cleaning contaminations and soils and things like that. And then pharmaceutical production. So pharmaceutical production is like drugs and medicine for people. Engineers figure out how to make them and how to make them less expensive, which is really important. And so when you see like the picture at the bottom, that's making a lot of something. And when you make a lot of something, it becomes less expensive. So let's talk about specific kinds of engineering. And I'm just going to kind of go through this pretty quickly. So mechanical engineering, mechanics, think more of like physics and math. You know, if you like to make things and break things, you might think about being a mechanical engineer. So, you know, hot fields are robotics, electric vehicle design, and, you know, the motors and the wheels. You could work for Nike. You could design shoes and understand the physics of the rubber squishing and wearing out. How comfortable is a person's foot? In space, you have rockets with a lot of stresses and so forth. Thank you, Goldilocks. I'll come back to that. So these are things that a mechanical engineer might do. So electrical engineering. So electrical engineering, everybody knows what electricity is. It's electrons and flowing through wires, and you can get a shock and voltage and current, resistance. Maybe you've heard that term. So electrical engineer can work in robotics, designing motors and controlling motors. Power grid management, that's a very important, as we move into a more sustainable energy portfolio, we need to develop our power grid and to figure out how inconsistent clean energy like sun and wind, how to feed that all in. And electrical engineers can be involved in that, but that's a very big challenge for us because of, you know, with fossil fuels, we can turn it on and off easily. With the sun and wind, we can't do that. Electronic circuit design, making little circuit boards for things you use in your home or whatever. Integrated circuits, so that is like the chips that are in your phones, your computers, what have you. Chemical engineering. So I'm a chemical engineer, so I intentionally put this third so I didn't demonstrate favoritism. But chemical engineers are everywhere. Chemical engineers often, chemical engineers are trained to think about the big picture, as I say, systems, what goes in, what goes out, and often end up in leadership positions because of that perspective. But chemical process industry, again, the coating on your desks, the lamination of the wood in your chair, the vinyl in your chair, etc. Chemical process industry, all those are made by chemical engineers. Chemical engineers are involved in solar cell production. They run the processes that make that stacked design in that cartoon there. The picture in the lower left might be of interest to you. So that's called a process flow diagram. Chemical engineers think a lot about that. What's going in, what happens, what goes out, how does it change? It might react, it might be filtered, what have you. And then the lower right is sort of a production line sort of scenario where you have stuff going in, stuff going out. And that's an example for a PV, which is a photovoltaic, so solar cells. Chemical engineer would be in charge of running that, making sure the quality is high and the parts run well. So bioengineering, and I taught bioengineering as well. Again, that bioengineering really focused on pharmaceuticals and biomedical devices. So, if we go from left to right, you can apply biological engineering to beer and wine making, because you've got enzymes and cells that are used to generate, to produce those beverages. Pharmaceutical production. So again, we talked about that example of driving the cost of drugs down once they're invented. And the lower right-hand corner is more biomedical, that's more mechanical, but devices like stents that would go in your artery, that's what that cylinder is. Environmental engineering. So environmental engineering, so in the upper left-hand corner is wastewater treatment. I talked about that in the bioremediation. Also very sort of process perspective, and the picture in the lower left demonstrates that. The lower right, you might be looking at how years of runoff from a gas station running down a hill into a stream, you might understand how that happens, the time, and how to clean it up. An environmental engineer would do that, civil engineer also. So those are different engineering disciplines. So now, again, in the spirit of putting you at ease, I want to talk about the basic things that you would do to enable a career in engineering and be one of those smiling people on that page one day. Okay, so the first thing is practice your math homework. And I very intentionally didn't say do your math homework. I said practice it, meaning practice your times tables, right? Practice the math problems that you've already solved. Do them again. You're very comfortable doing it over and over again so that your confidence gets high. Because what I see and what's been demonstrated, especially with girls in underrepresented groups, is there's this idea, quote, I'm not good at math, unquote. Once you say that, you allow yourself to say that about anything, then you're not good at math, okay? So anytime in life you get a chance to try something and it's hard, keep trying, make it simpler, try again, talk to someone. Practice your math homework. Don't just do your math homework. The other thing I advise you to is practice drawing a lot. Now you might be thinking, this is a pretty complicated drawing. I could never do something like this myself. I don't want you to be intimidated by the drawing, but if you practice drawing, it's a great way to communicate. And with time, you get better and better at it. So drawing is really important. Like you might draw your bedroom desk if you have a desk and a computer in your room. Practice drawing because it forces you to make a physical representation that includes sort of a geometry and numbers sort of thing. Like, how big is my desk? How big is my desk compared to my computer monitor? How tall is it? So it's really good for your brain development. Also, when you become an engineering student and eventually an engineer, people that are comfortable drawing end up being more successful. And I saw this over and over again as a professor, and I see it now as I lead groups of engineers, that if you're comfortable drawing, you lead discussions and you make your team better and everybody's happier. So draw a lot. The next thing is to be interested. Be interested in things that you don't understand, and it doesn't necessarily have to be science. You know, how is this person's sickness treated? Where does the water from my sink go? Crawl under your sink and follow the pipe. Get in trouble with your mom and crawl under the house and figure out where that goes. Then come back and tell your mom, I'm sorry, I'm dirty, but I know where our water goes after I flush the toilet. All right, that's really important. Be interested and practice reading. Read to increasing levels of depth and so forth. So, and then the last thing that's really important if you want to be an engineer is practice working with others. So that means listening to other people, having the courage to share your ideas, even if a mean person giggles at them because that person's insecure. Be the strong person, share your ideas, talk to others, celebrate the ideas of others and the accomplishments of others. And the more you practice that, the easier it'll get. Why does that matter for an engineer? Because when you go to college, it's going to be really good to have friends with whom you study and a diverse group of friends with different ideas and approaches. And you'll be ready for that. And the classes will be much easier and college will be more fun. Then when you work as an engineer like I do, I have a broad range of people with whom I work, and I really enjoy human beings. And so that works very well for me. So these are the 4 things that I suggest that you do if you are interested in being an engineer. And you'll notice that I'm not saying get straight A's. I'm not saying take certain classes. These are general behaviors that will psychologically position you to succeed. And that's what I really hope to do in this talk. So before I close it, Goldilocks had the question, what is the most popular engineering degree? I'm going to guess, I'm going to guess that it's mechanical engineering. And if I'm wrong, it might be electrical. And then what is the most highly paid? Historically, chemical engineers are the most highly paid. In fact, to be honest with you, when I graduated from high school, I said, I'm never going to be without money again. And that's why I chose chemical engineering. And I was good at math and chemistry, and that's why I chose it. And now I love it. Now I just love it because I see it everywhere. But also the computer science majors, Goldilocks, and electrical and just computer. Even though I didn't talk about computer science engineers, that's sort of an engineering field. You know, they write a lot of computer code. But less of like the hands-on stuff that some people speculated early. So how is civil apart from environmental engineering? That's a great question. So civil engineering, Jeffrey, is generally structures like walls, roads, things like that. Environmental engineering takes that knowledge and applies it to building like a wastewater treatment plant or something like that. And I also taught environmental engineering, but it was more from a chemical engineering perspective for the treatment, you know, the flows and wastewater treatment. So that's a good question. So Goldilocks asks, what is the best soft skill for an engineer? The best soft skill, really what I've listed in front of you here are soft skills. And I'm going to guess of those, what would I say? Oh, I hate to prioritize. I refuse, Goldilocks. I refuse. All 4 of these are important because if you're if you're good at 1 or 2 of these, it can really make a huge difference. Okay. If you're super shy and aren't really good at talking to other people, you can still be a good engineer if you're interested and you draw a lot and you practice your math homework. So it really is all four of these things in my mind. Karen asked, what disciplines is currently the most needed? I'm embarrassed I don't have an answer to that. But I would again guess that they're all needed. When the economy goes well, people invest, businesses grow. I'd say that computer science engineers are pretty in high need. So that's a good question. Was there a time when you thought this career degree is super hard and you won't make it? Absolutely. So let me tell you a specific experience I had. So as an undergrad, because of my situation, I didn't have calculus in high school, but I was good at math, and I tested into the calculus class, and I didn't have any idea what was going on, and I failed the first exam badly. So there were 15 hard multiple choice problems that you work through, and I got 5 out of 15. And I knew at that moment, I was a pretty wise kid, Goldilocks, I gotta say. I knew at that moment that my self-image would be severely damaged if I stayed in the class. And so I walked away from the class. I took an F in the class, and I studied calculus on my own for 2 months or a month or whatever. And then I retook that class and I got an A. So I was terrified. I didn't know if I could make it, but I knew that if I thought badly of myself, it would be difficult. So that would be a time. So then there's a question from Karen, what discipline can help play a vital role addressing climate change? Great idea. All engineering, all of it. You saw that the examples I gave, there was some climate or sustainability related aspects to everything. I would ask anyone else, which one doesn't? And there's no answer. All of them are needed, and it's how you direct yourself. Is engineering hard to get into? Yes and no. So if you practice these things now, I don't know if I'm talking to seniors, I don't know, but if you practice these things, you position yourselves to get in. And there's different schools that have higher levels, to get in and what have you. But that's my answer for that. Would I choose this career if you could make the decision again? Absolutely. I wouldn't change a thing in my life. I am grateful for the challenges I have and decisions I made and the people I've been privileged to work with. And I don't do a lot of what if anymore at all. Life's pretty good for Dr. Phil. So what is the hiring outlook for this career? So very good. So the salaries, in engineering starts whatever, $60,000 to $80,000. And that's a lot of money, I think. And depending on where you are in your thing, money is more or less important, right? But the hiring outlook is always going to be promising for engineers in general. Put it this way: if you're going to go to college, and you don't have to, by the way, there's a lot of things you can do in your career. But if you're going to go to college, what else are you going to do if you're interested in money and getting a job? I would ask that too. Okay. What do you wish you knew but didn't when you first contemplated this career? That's kind of related to the last one. Would I do anything differently, right? Because it's inferring that if I had information, I would have made a different decision. I think I got lucky in that I chose chemical engineering because I was good at math and chemistry, and I wanted to make a lot of money at the time. But after I get into it and applied it and had my successes in my career, that it was very natural for me. So it turns out I made the right choice. And I had a lot of mentors. Part of being interested in read is in practice working with others is talking to people that know more than you. I had pivotal moments in my career, Goldilocks, where people, I'll just tell you one is when I was working in industry, I had a chance to go and get my master's degree, and I went to a mentor, and I asked him, would you do this if you were me? Would you go? And he looked at me and he said, you'd be an idiot not to. And so I was scared. I didn't know if I'd succeed, but when that mentor, who I know was very firm, but I knew he loved me, it's like, oh, I have no choice now. So talking to people that will give you opinions, and you have to balance those opinions with, who it's coming from. But that's something to practice doing too. I don't, for lack of a better way to say it, practice talking to grown-ups, you guys. Practice, all of you should be on camera right now. All right. You're putting me in a very tough spot by making me speak to black boxes. Practice talking to grown-ups and not being scared, because grown-ups love you and don't want to hurt you, and they want you to have a great future. So that's a key piece. And the students that I see that are comfortable talking to more experienced human beings end up having many more opportunities and seeing more potential. So then I have a question. Does this career provide the opportunity to balance time between work and family? Absolutely. Absolutely. So most engineering jobs are, 40-hour week jobs. And like any job, you have periods of being very, very busy or working late. I personally love my work. So if I'm on vacation and I have to work for 2 hours in the morning to help my team move along, it's not a problem for me. I don't do it very often, but it's not a problem. It's part of just enjoying what I do and serving my team as best I can. Do you need a license to become boy, Goldilocks, if she could get $100 for every question she asked, she'd be retiring. Do you need a license? That's a great question too. You may have seen somewhere in my portfolio that I'm a PE, which is a certified or licensed professional engineer. And so the answer is yes. So the way that process goes is you finish your degree in engineering, and then you take an exam, then you work for a few years, and then you take another exam. So I did that in the field of chemical engineering and passed those exams, and I'm a certified professional engineer. And then you say, why does that matter? Well, if I wanted to go and design, say, a chemical reactor as a consultant, I can sign off on it, and there's some legal ramifications about that. I've done it, I did it, I maintain mine, but I don't use it. All right, how we doing? Last question. How much do you make, Dr. Hardy? I'm not going to answer that question. More than I need. How about that? But it's like in all seriousness, if you do these 4 things throughout your career, I still draw a lot. I still practice working with people. Good things happen, and you get rewarded. And it takes all kinds too. I personally hate this term leader, because I think it has a disproportionately intimidating effect on underrepresented groups and girls who are thinking about engineering. I just don't like the word. I think you just do your best, and you interact with your team, and you figure out how best to serve your team. And sometimes it's nose to the grindstone, working really hard. Sometimes it's saying, okay, I'll help organize, or I'll make a decision. And so there's a variety of ways. And you do those things, the money will come, Goldilocks. All right, let's see. Jeffrey's got a question. Is it enough to sustain yourself? Oh, yes. Yeah, no, engineering is a great living, you guys. So engineers make very, very good money. And as you can tell, I just don't like focusing on money. So I'm uncharacteristically tripping over my words right now. But yes, engineering is a great way to have a healthy livelihood, make a lot of money, have benefits, have a car, eventually buy a house, pay for your kids' college. Does that work, Jeffrey? Okay. All right, thanks. Anything else? All right. Well, thank you very much. And Goldilocks, do they need to do anything? Do I hand it back to you?
No, that's it. We're good. Thank you so much for volunteering your time. We kind of have a little shy group today, but I'm very curious, so I'm always have questions.
Yeah, you did a great job.
So I'm
right.
gonna stop the recording.
Okay.